Hi everybody. Today in this class we shall learn something details about electromagnetic induction. Electromagnetic induction. In olden days, it was thought that electricity is a different branch from magnetism. But the scientists named Ampere, Oersted, Henry and Faraday, because of these scientists, a new branch of electricity, that is electromagnetic induction, was laid foundation. They said that electric current carrying wire one wire, it can deflect magnetic needle. It has deflected magnetic needle. Okay. So based on this, they said that varying magnetic field can produce electric current. So whenever there is a change in the magnetic field, it can produce electric current. This was proved by the series of experiments done by the Ampere, Oersted, Henry and Faraday. And in their experiment, they said that whenever there is a wire, it is connected to a galvanometer and there is a bar magnet. It is brought near to the wire. Whenever this bar magnet is brought close to this wire, there is a change in the magnetic flux linked with this coil. There is a change in the magnetic flux linked with this coil due to this bar magnet. So the magnetic flux is varying, it is changing. Due to this change in the magnetic flux, it is producing some induced current in the coil. In the coil it is producing some induced current. So as a result of that, what happened? Due to this induced current, the galvanometer is showing some deflection. It is showing some deflection. The galvanometer is getting deflect whenever this bar magnet is got near to this coil. So from this, what we understood is the induced EMF is directly proportional to change in the magnetic flux, varying magnetic flux. So first of all, what do you mean by flux here? Flux means nothing but whenever there is a uniform magnetic field, this is a uniform magnetic field B, and there is a plane, assumed plane placed in the uniform magnetic field. The number of lines passing through this plane, that is called as the magnetic flux. And the area of this plane is nothing but, it is perpendicular drawn to this plane. Aerial vector. Magnetic field is also a vector quantity. Now this aerial vector is making some angle theta with the plane. Its component along this line is, along the magnetic field is A cos theta. So the product of the component of aerial vector along the magnetic field and the magnetic field, These two product will give rise to magnetic flux. This is a magnetic flux. Due to bar magnet, B is equal to B dot A we can write. This is a magnetic flux. Right? First of all, what is electromagnetic induction means? Varying magnetic field is producing electric current. This phenomenon we call it as electromagnetic induction. For this, who has laid the foundation means Oersted, Ampere, Henry, Faraday. These are the scientists. They laid foundation. And here, varying magnetic field, electric current. How we can show it experimentally means this is the coil and this is a magnet. We are moving the magnet towards the coil. There is a change in the magnetic flux linked with the coil. So this change in the magnetic flux linked with the coil induces some electric current in the coil. So that is I, induced electric current, and that induced electric field is nothing but due to change in the magnetic flux linked with the coil. So we can write E is proportional to d phi by dt. This is Faraday's law, and flux formula can be calculated like this. We are considering a small element having a plane area A, and the number of lines passing through this plane area are calculated. That is phi b is equal to magnetic field. The strength of the magnetic field is more number of lines will be passed through, and strength of the magnetic field is less number of lines will be passing through that one. So the number of lines passing through that magnetic field, that can be calculated. Phi b is equal to the strength of the magnetic field into area. That area is completely parallel to the field. Maximum number of lines will be passing through. If it is, the area is tilted, if the face is not exactly parallel, that is aerial vector is not parallel to the magnetic lines of force, then it is making some angle, then it will be making some angle here like this. It is parallel now, it is making some angle. So the component of this aerial vector along this line we have taken, that is a cos theta, multiplication of this magnitude and a cos theta will give you the magnetic flux of that particular plane, of that particular field. That is magnetic flux is equal to BA cos theta. But BA cos theta is just like in a scalar product we have seen, AB cos theta can be written as a dot product of two scalars, that is A dot B. So similarly, in the case of here, we write two vectors are there, suppose A, small b, you take two vectors. Then what we can write? We can write the dot product of these two vectors. A is a vector, small a is a vector, small b is a vector. Then the dot product of these two vectors we can write AB cos theta. So here also it is BA cos theta and its dot product can be written like this. Okay? Right. Next, in how many ways the induced EMF can be produced? In how many ways? Number one, first case. The first case, coil with galvanometer is at rest and bar magnet is moved. Bar magnet is moved. Then induced EMF is in the coil. Number two, in second case, now coil with galvanometer is moved and bar magnet is at rest. Bar magnet is at rest, the coil is moved, then also induced EMF is produced. Okay. Next, the third case, coil with galvanometer and coil with battery is taken. With the battery, it is moved towards the coil with galvanometer. Then also induced EMF is produced in the coil with galvanometer. And next, Now the coil, the galvanometer is moved towards a coil with a battery. It is at rest. Then also the induced EMF is produced. Next, coil with the galvanometer is at rest only, and coil with the battery is also at rest only. It is also at rest only. But the current through the coil is changed. Whenever it is switched on and switched off, there is a deflection in the galvanometer. Galvanometer deflects when tap key on or off. When tap key is on or off, the galvanometer will be deflecting. If it is pressed constantly, there is no deflection in the galvanometer. So this is the thing when induced EMF is produced. Induced EMF is produced in these varieties. Induced EMF is produced. In these cases, induced EMF will be produced. Next, Lenz's law and conservation of energy. So, what is Lenz's law and conservation of energy? Lenz's law said that whenever there is a coil, it is connected to a galvanometer. This is a magnet, bar magnet. Whenever north pole is moved towards the coil, then the current will be produced in a anti-clockwise direction. Anti-clockwise direction. The current will be in anti-clockwise direction. The current, when the north pole is moved towards a coil. If a south pole is moved towards a coil, if a south pole is moved towards a coil, south pole is moved towards the coil, then in a clockwise direction, the current will be produced. In clockwise direction, in this direction, the current will be produced. So this is south pole. And the reverse case for this, or north to south, it is taken away from the coil, then also clockwise will be produced. And for this, when the south pole is taken away from the coil also, same anti-clockwise direction, the current will be produced. Okay, so this is the Lenz's law. Lenz's law has given the sign convention for this Faraday's law. According to Faraday's law, what we have said is EMF is equal to D is proportional to d phi by dt, we said. EMF is proportional to d phi by dt, we said. Now in this, EMF is equal to, we can write minus d phi by dt. So here this minus sign indicates that always the induced EMF opposes the change in the magnetic field that is caused. Change in the magnetic field is positive, then induced EMF will be negative for that one. It produces opposite in direction. 2. In order to make the energy conservation holds good in this case. That means whenever we are moving this bar magnet towards the coil, some kinetic energy is transformed, and this kinetic energy is transformed into some heat. Okay, dissipation of heat energy is taking place between the what we call electrons, that flow of charges inside the wire. Okay, in the form of heat energy, that whatever the energy that is created, this is converted. So law of conservation of energy holds good in this case. So the Lenz has corrected this equation by keeping the minus sign. Okay, this minus sign indicates the law of conservation of energy. Next we talk about what are the equations we got so far. Now let us see. Number one, first one what we have got is phi is equal to B dot A, recollection we shall see. Next we got phi is equal to BA cos theta we got. Next we got E is equal to, we got minus d phi by dt we got. Okay, these are the equations we got so far. Okay, next we shall see in the now we talk about induction. In induction, what is happening is the magnetic flux is directly proportional to the current. From all these three experiments before we have seen, whenever there is a change in the current, it is producing the change in the magnetic flux. So that's why we can write d phi by dt is also proportional to di by dt we can write. Okay. Next from this what we can write is induction is again two types. We have two types of inductions here. One is mutual inductance, and the other one is self induction. Okay, so we shall take first mutual inductance. In mutual inductance, now we are taking one coil we are taking having n turns. Inside this coil another small coil we are taking having n2 turns, and size of this one is you take as L, and here this radius is you take it as R2, and this one the radius is R1, and number of turns linked to this one is N1, and number of turns linked to this one is N2, right? And now we already know that phi is directly proportional to I. So I am taking phi 1, the magnetic flux linked to the first coil is due to the electric current flowing through the second coil. The current flowing through the second coil is I2. Current flowing through the first coil is I1. So whatever the flux linked with the first coil is due to flux linked to the second coil. So here we can write N1 because the total number of coils in the first series of coils, the number of turns in the first coil is N1. So N1 is proportional to I2. If you remove the proportionality symbol, we get N1 is equal to M12 mutual inductance of the first coil due to second coil, M12 into I2. This is the equation for the mutual inductance of the first coil. Similarly, we can write the mutual inductance of the second coil also we can write. What is that? Mutual inductance of the second coil, what we can write? N2 Phi2 is equal to M21 I1. M21 I1. This is the mutual inductance due to second coil on first coil, and the current is due to first coil. The current flowing through first coil is inducing some magnetic flux to the second coil. Now, what are the equations we got here? Phi 1 N1 is equal to M12 I2. N2 Phi 2 is equal to M21 I1. These are the two equations we got. Magnetic flux linked with the second coil is due to current through first coil. Magnetic flux through first coil linked with the first coil is due to current through second coil. Now we have a formula about N1 Phi 1 is also equal to the total number of coils, that is N, and area of BA. Phi is equal to BA now. So we can write BA and BA. So here total N we can represent as the number of coils, that is N1, and length of the total coil is L. Right? We get NL. And area of the first coil is nothing but, it is in the form of a circle. So pi R1 square. And B value is mu N I, that is due to second coil, and magnetic field is due to second number of coils due to second coil. So substitute these values in this, what we get? N1 Phi 1 is equal to N1 N2 mu, N1 into N2 mu, and pi R1 square. L is there and I is there, L I2. Okay, this is a N1 Phi 1 value. Similarly, now we can equate these two things. This is equal to M12 I2, and this is equal to N1 Phi 1, that is equal to N1 N2 mu pi R1 square L I2. We can equate these two equations. When LHS sides are equal, we can equate their RHS sides. So we can get M12 is equal to, what do we get? N1 N2 mu pi R1 square L I2 into I2. So here M12 into I2. I2 and I2 get cancelled. I2 and I2 get cancelled. So what is remaining here? M12 is equal to N1 N2 mu pi R1 square L we got. Similarly, we can find out this M21 I also, because N2 Phi 2 value you write down. N2 Phi 2 means N2 is nothing but small n2 into L. Area is nothing but pi R1 square, and B is nothing but mu N1 I1. So here you should get a doubt that Why we have taken this pi R1 square for N2? Because length of the coil is very much greater than R2. So induction is permissible for R1 radius only. So that's why we are taking, instead of R2 we are taking R1. So here you again equate these two equations. These two equations you equate. What we get is M21 I1 must be equal to N2L pi R1 square mu N1 I1. I1 get cancelled. So what will get M21 is N1 N2 mu pi R1 square into L. So these two mutual inductances are showing same result. So we can conclude that the mutual inductance on the first coil, primary coil, due to secondary coil is equal to the mutual inductance on secondary coil due to primary coil. Both are equal to M value. This is about mutual inductances that we have concluded about the inductance. Similarly, now we talk about the self-inductance. There is a coil and we are supplying some EMF to this coil. And the current is varying in this coil. Due to the variation of the current, the magnetic flux linked with the coil is also varying. In the same coil. So this type of phenomenon we call it as a self-inductance. Now here also we can take like this, phi is equal to, first of all it is proportional to I, d phi by dt is also proportional to di by dt. So from this first equation what we can write is phi proportional to I. This implies phi is equal to L into I. This L is called as the self-inductance proportionality constant. And it is also a type of inertia. This is electrical inertia. And this is analogous to mass in the mechanics. In mechanics, we talk about mass. In electricity, electromagnetics, we talk about inductance. Right? It is also a electrical inertia. This is electrical inertia. It is measured in Henry. SI unit of inductance is Henry. Okay. So these are the things about self-inductance. Now, we know that phi is equal to Li, d phi by dt is equal to L into di by dt. Next, E is equal to minus d phi by dt. Induced EMF is change in the magnetic flux. Again, phi d phi by dt we can reproduce this. Induced EMF is equal to minus L into di by dt. Now we already came to know about this I value, right? So we can this is nothing but power dW by dt is equal to, we can write E into I. The power, rate of change of work is power. Power is nothing but EMF into current, V into I. So now what we can write is, already we got E value, substitute in this. So what do we get here? dW by dt is equal to minus L into I into di by dt. We can write like this. dt both sides we can get cancelled. So remaining what we get here is dW is equal to minus Li dt. Integrating on both sides, we get integral dW is equal to minus integral L into I di. So here we are increasing the current from 0 to I. So what we get is dW is equal to minus half Li square. As we take this in modulus, because work is a scalar quantity, so everything will be in modulus. It is a positive work done, so that's why integral W is nothing but W is equal to half Li square. This is the work done in the self inductance to draw the current from 0 to I. We are changing the current from 0 to I. During that time, how much work is done means total work done is, energy stored in the self inductor is half Li square. Now we got that energy stored, work done or energy stored is half Li square we got, but B is equal to what we know, mu N I, and from this I we can write as B by mu N, and L is equal to what we got, L is equal to mu N square. We know the formula, L is equal to what is the formula we got just now? We know that phi is equal to Li, we know, and phi is equal to B A. This we know. So equating these two things, what we get is B is nothing but mu N I, A is nothing but pi r square, and L is nothing but L into I. So I get cancelled. So L is equal to what we get is mu N pi r square. And this is for 1, and total length is nothing but n, we have to multiply, so nl will be there. So from this what we will get, mu n square pi r square into l, this is l, so mu n square pi r square into l, this we got l value. Now substituting this, what we get is, substitute these values in this, so we get energy stored, that is U is equal to half into mu n square pi r square into L divided into I square means this one, b square by mu n, that is mu square n square. We are writing here small n, instead of capital N we are writing small n. So now we can write n square get cancelled, mu and here mu get cancelled. So what we get here is A, area, this is A into L, b square by 2 mu. This is the energy stored in the magnetic field. Energy stored in the magnetic field. A into L is nothing but volume V. This you can send outside. You will get energy stored per unit volume is d square by 2 mu. Similarly, in the electric field, energy stored per unit volume is half epsilon naught E square. Like this we get the two different relations for energy stored in the magnetic field, energy stored in the electric field. Energy stored in the magnetic field is b square by 2 mu or mu naught you can take. Here energy stored in the electric field is half epsilon naught E square. Like this we can calculate the energy stored in the magnetic field and electric field. Next. So based on this induction, mutual induction and self-induction, we have one more application of this electromagnetics, that is AC generator is there. Right? So how this AC generator will work actually? AC generator. So how this AC generator will work actually means, see we have two R2 magnets and this is a coil, and we have two slip rings connected to some brushes. These are the two brushes, P1, P2, S1, S2, slip rings, brushes, magnets. This is armature. Okay. Now we have just a relation, what is that? Phi is equal to BA, we got B dot A, or phi is equal to BA cos theta, we got, and E is equal to d phi by dt, we got, minus d phi by dt, and E is equal to minus d by dt of BA cos theta. Here theta is equal to what we will take, as it is rotating with a velocity, angular velocity omega in t seconds, then we can write theta is equal to, angular displacement is angular velocity into time. omega t. So here what we can write is E is equal to minus d by dt of BA cos omega t. After integrating on both sides, what we get is, this is you take it as a small change in the current. So on integrating, what we get is E is equal to, for one coil it is BA, for n coils it is NBA. If there are n coils, we can take NBA, n into BA we can take. So NBA omega sin omega t, E is equal to, we will get n pi omega sin omega t, NBA omega sin omega t. Now what we can take is this NBA sin omega t is equal to 90 degrees. That means when it is horizontal, then whatever the aerial vector is there, it will be perpendicular to the magnetic field. Magnetic field is from here to here. So the magnetic field will be perpendicular to, the aerial vector will be perpendicular, the aerial vector of the plane is perpendicular to magnetic field. So theta is equal to 90 degrees. At theta is equal to 90 degrees, we get sin 90 is equal to 1. It is the maximum value of sin, right? So that's why we will get E is equal to E naught is equal to NBA omega. So whenever it is horizontal, whenever this armature is horizontal to this magnetic lines, of course, then we get maximum value for EMF, that is nothing but NBA omega. When it is vertical, then we get theta is equal to 0 degrees. So as a result of that, what happen? Sin theta is equal to 0. So we will get minimum. When it is a minimum, and how it will be rotating means, this can be rotated using our mechanical energy. So AC generator is nothing but it converts mechanical energy to electrical energy. It will convert mechanical energy to electrical energy. And it is varying. Its graph is varying. Right? Okay. It is having maximum value, minimum value, maximum value, minimum, like that it goes on. So when it is horizontal, it will be maximum. When it is vertical, it will be minimum. So using this, we can say about this AC generator. Next we talk about motional EMF. Motional EMF. Motional EMF. So in this motional EMF, we are taking a U-shaped frame, and its length is we are taking as L. Magnetic lines of course is perpendicular to this board. So they are all perpendicular to this board. We are applying a magnetic field perpendicular to this, and there is a movable stick, metal. It is moving. Stack is AB, and this is CD. Right? So ABCD is a frame, metal frame. On this AB is a glider. It will be moving. It will be moving with velocity v towards left. Right? So now we talk about magnetic field is nothing but B dot A. The area of this, as it moves towards the left, the area of this plane is decreasing. We already know that when phi is equal to NBA cos theta, if magnetic field is varied, magnetic flux varies. If area is varied, magnetic flux is varies. If theta is varied, then also magnetic flux will be varied. So on what factors the magnetic flux is depending upon? It is depending upon 1, 2, 3, 4 things. So it is varied due to number of coils and magnetic field and area and theta. On these 4 factors it is depending upon. So here which factor we have taken? Area factor we are taking, and it is decreasing. Area is decreasing in this section. Now you take this as length as L and this one B to C as X. Now this area will be is equal to X into L. So now what we can write, phi is equal to B into L into X. Right? Now this plane is exactly what is called, we can say it is parallel to this. So here this theta value we are taking as 0 degrees. So cos 0 is 1. So that's why we talk about only BA. So only one coil is there. N is equal to also 1. So phi is equal to B into L into X. Now I want E, that is d phi by dt. Negative rate of change of flux. So what we can say here now, E is equal to minus d phi by dt means d by dt of BLX. So we can write as minus d by dt of X, that is E is equal to minus B into L. B is a constant here, no change in the flux. Magnetic flux is not changing, it is constant. And length between C and D is also remains constant. No change in that one. Only the varying thing is here, X value is changing. It is decreasing as we are moving towards the CD. So we get dx by dt. That is nothing but V. V is equal to dx by dt. Velocity of the rod towards CD. So we can write here as E is equal to minus BLV. This is called motional EMF. Here EMF is said it is acting like a battery. The current is flowing in this direction in this case, A to B, because you take it as a, this is a velocity of this and this is a magnetic flux perpendicular to this, and this thumb shows the current that is acting downwards. So like this we are talking about the motional EMF, right? Next. Thank you.